Welcome to the session. My name is Priya N, lecturer, Government Polytechnic Immediately. I am going to present Program 5 Implementation of Knapsack Problem of Design and Analysis of Algorithms Lab 5th Semester Diploma. Now we'll see the aim of experiment. Program to implement the Knapsack Problem. So ಇಲ್ಲಿ ನೀವು ನೋಡ್ಬೋದು knapsack is nothing but one bag of some weight. Maximum weight is 15 kg. ಇಲ್ಲಿ ನಿಮಗೆ ಡಿಫ್ರೆಂಟ್ ಐಟಮ್ಸ್ ಇದೆ. ಸೊ ನೀವು ಈ ಐಟಮ್ಸ್ನ ಈ ಬ್ಯಾಗ್ ಒಳಗಡೆ ಹಾಕಬೇಕು. ಸೊ ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಐಟಮ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಈಚ್ ಐಟಮ್ ವಿಚ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ದ ವೆಯ್ಟ್ with respect to item 1, the weight is 12 kg and the profit is $4. Let us consider another item. The weight is 2 kg and profit is 2. So if you put this item here, so ಈ item ನೀವೇನಾದರೂ ಬ್ಯಾಗಲ್ಲಿ ಹಾಕಬೇಕಾದ್ರೆ, so you need to check the weight of this item. The weight of this item is 2 kg. Here the bag capacity is 15 kg. We can put it, right? ಸೊ ನಾವೇನಾದರೂ ಈ ಐಟಮ್ನ ಬ್ಯಾಗಲ್ಲಿ ಹಾಕಿದ್ರೆ ನಮಗೆ ಪ್ರಾಫಿಟ್ ಸಿಗೋದು $2. ಅದೇ ಈ ಐಟಮ್ನ ಏನಾದರೂ ಹಾಕಿದ್ರೆ ಸೊ ನಮಗೆ ಪ್ರಾಫಿಟ್ ಸಿಗೋದು 4. ಸೊ ಸಪೋಸ್ ಈ ಐಟಮ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಇದ್ರದ್ದು ವೆಯ್ಟು 1 kg ವಿಚ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 15 kg. ಸೊ ನಾವು ಈ ಐಟಮ್ನ ಈ ಬ್ಯಾಗಲ್ಲಿ ಹಾಕ್ಬೋದು, ಬಟ್ ಹಾಕಿದ್ರೆ ನಮಗೆ ಸಿಗೋ ಪ್ರಾಫಿಟ್ಟು 2. ಅದೇ ರೀತಿ ಈ ಐಟಮ್ ಹಾಕಿದ್ರೆ ಸೊ ಬಿಫೋರ್ ಪುಟ್ಟಿಂಗ್ ದಿಸ್ ಐಟಮ್ ಇನ್ ಟು ದ ಬ್ಯಾಗ್ ವಿ ಆರ್ ಚೆಕಿಂಗ್ ವೆದರ್ ದ ವೆಯ್ಟ್ ಆಫ್ ದಿಸ್ ಐಟಮ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ದಿಸ್ ಬ್ಯಾಗ್. ಎಸ್ ಟ್ರೂ, 4 kg, it is less than 15 kg, we can put this item into the bag. So if we put this item only to the bag, we will get the profit $10. Otherwise let us go for this item. For this item the weight is 1 kg which is less than 15 kg, so that we can put this item to the bag, but we will get the profit $1. So this is the way how we can put items into the bag. Before putting the item into the bag, we need to check the weight of the item should not be greater than the capacity of the bag, capacity of the knapsack. And one more thing, so while putting the items, so ನೀವೇನಾದರೂ ಈ ಮ್ಯಾಕ್ಸಿಮಮ್ ನೀವು ಪ್ರಾಫಿಟ್ ಸಿಗಬೇಕು ಆ ಥರ ಐಟಮ್ಸ್ನ ಈ ಬ್ಯಾಗಲ್ಲಿ ಹಾಕಬೇಕು. ಎಕ್ಸಾಂಪಲ್ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಫಸ್ಟ್ ಒನ್ ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಒನ್. ಇವೆರಡು ಐಟಮ್ ಹಾಕಿದ್ರೆ ನೋಡಿ ಇದ್ರದ್ದು ವೆಯ್ಟು 12, ಈ ಐಟಮ್ದು ವೆಯ್ಟು 1. 12 + 1 13 kg. 13 kg is less than 15 kg. ಸೊ ಇವೆರಡು ಐಟಮ್ನ ನಾವು ಬ್ಯಾಗಲ್ಲಿ ಹಾಕ್ಬೋದು. ಹಾಕಿದ್ರೆ ನಮಗೆ ಸಿಗೋ ಪ್ರಾಫಿಟ್ಟು 4 + 2 $6 ಸಿಗುತ್ತೆ. ಓಕೆ, ಸೊ ಅದೇ ರೀತಿ ವಿ ಕ್ಯಾನ್ ಗ್ರೂಪ್ ದ ಐಟಮ್ಸ್ ಆ್ಯಂಡ್ ಆಲ್ಸೋ ವಿ ಕ್ಯಾನ್ ಪುಟ್ ಇನ್ ಟು ದ ಬ್ಯಾಗ್. ಗ್ರೂಪ್ ಮಾಡಿದಾಗ ನಾವು ಟೋಟಲ್ ವೆಯ್ಟನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಈ ಸಪೋಸ್ ಇವೆರಡನ್ನ ಗ್ರೂಪ್ ಮಾಡಿದ್ರೆ ಈ ಟೋಟಲ್ ವೆಯ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ದಿಸ್ ವೆಯ್ಟ್, ಟೋಟಲ್ ವೆಯ್ಟ್ ಶುಡ್ ನಾಟ್ ಎಕ್ಸೀಡ್ ದ ವೆಯ್ಟ್ ಆಫ್ ದ knapsack. Okay, so example we are just doing the subset, we are just doing the combination, this item and this item, or else we can do this with this, or else we can do this with the this and this with the this. Like that we can do so combinations. So let us consider this and this. Here this is 12 kg, this is 2 kg. 12 + 2 ಅಂದರೆ 14 kg. 14 kg is less than 15. ಸೊ ಇವೆರಡು ಐಟಮ್ನ ನಾವು ಬ್ಯಾಗಲ್ಲಿ ಹಾಕ್ಬೋದು. ಇಫ್ ವಿ ಪುಟ್ ದೀಸ್ 2 items into the bag, we will get the profit 4 + 2, that is $6. ಇವೆರಡು ಹಾಕಿದ್ರೂ $6 ಸಿಗುತ್ತೆ, ಇವೆರಡು ಹಾಕಿದ್ರೂ $6 ಸಿಗುತ್ತೆ. ಲೆಟ್ ಅಸ್ ಟೇಕ್ ದಿಸ್ ಆ್ಯಂಡ್ ದಿಸ್. ನೋಡಿ ಇವೆರಡು ತೊಗೊಂಡ್ರೆ ಇಲ್ಲಿ ಇದ್ರದ್ದು ವೆಯ್ಟು 12 kg ಇದೆ, ಇದ್ರದ್ದು ವೆಯ್ಟು 4 kg ಇದೆ. 12 + 4, that is 16. 12 + 4 is 16 kg. 16 kg, can we put these two items into the bag? It is not possible since the capacity of the bag is 15 kg, but after combining these two weight it comes around 16 kg, right? So 16 kg ಇದು ಇರೋದೇ 15, 16 ಹಾಕಲಿಕ್ಕೆ ಬರಲ್ಲ. ಸೊ ಇಫ್ ಏನಾದರೂ ಆ ಥರ ಹಾಕ್ಲಿಕ್ಕೆ ಬಂದಿದ್ದಿದ್ರೆ ಸೊ ವಿ ವುಡ್ ಹ್ಯಾವ್ ಗೆಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಫಿಟ್ ದಟ್ ಈಸ್ 10 and 4 $14 ಬರ್ತಿತ್ತು. ಬಟ್ ನಮಗೆ ಹಾಕೋಕ್ಕಾಗ್ತಾ ಇಲ್ಲ ಬಿಕಾಸ್ ವೆಯ್ಟ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ದ ಕೆಪಾಸಿಟಿ ಆಫ್ ದ ಬ್ಯಾಗ್. ಸೊ ಹಿಯರ್ ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದಟ್ ವಿ ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ದಿಸ್ ಆ್ಯಂಡ್ ದಿಸ್. ಸೊ ಈ ಥರ ಹೋದರೆ ಸಪೋಸ್ 12 and 1 13 kg ಆಗುತ್ತೆ. 13 kg ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 15. ಸೊ ಇವೆರಡು ಐಟಮ್ನ ನಾವು ಬ್ಯಾಗಲ್ಲಿ ಹಾಕ್ಬೋದು. ಹಾಕಿದ್ರೆ ನಮಗೆ ಸಿಗೋ ಪ್ರಾಫಿಟ್ಟು 4 + 1 5. ಇವೆರಡು ಹಾಕಿದ್ರೆ $6, ಇವೆರಡು ಹಾಕಿದ್ರೆ $6, ಇವೆರಡು ಹಾಕಿದ್ರೆ $5 ಸಿಗುತ್ತೆ. ಬಟ್ ಇವೆರಡು ಹಾಕಿದ್ರೆ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಫಿಟ್ ಸಿಗುತ್ತೆ, ಬಟ್ ವೆಯ್ಟ್ ಎಕ್ಸೀಡ್ ಆಗೋದ್ರಿಂದ ಇವೆರಡನ್ನ ಹಾಕೋಕ್ಕೆ ಆಗಲ್ಲ. ದಿಸ್ ಈಸ್ ಇನ್ಫೀಸಿಬಲ್ ಸಬ್ಸೆಟ್. ಸೊ ಓಕೆ, ಲೆಟ್ ಅಸ್ ಡಿವೈಡ್ ದಿಸ್ ಐಟಮ್ ಆ್ಯಂಡ್ ಪುಟ್. ಅರ್ಧ ಏನಾದರೂ ಕಟ್ ಮಾಡಿಬಿಟ್ಟು ಈ ಐಟಮ್ನ ಹಾಕ್ಬೋದಾ? ಇದು ಹಾಕ್ಲಿಕ್ಕಾಗುತ್ತಾ? ಸೊ ದಟ್ ವಿಲ್ ಗೆಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಫಿಟ್. This is not possible. Why? This knapsack problem we can observe here 0 to 1. That is, there are two variants of questions. One is fractional knapsack, second one is 0 to 1. What happens in fractional variant, which allows you to break the items so to maximize the value in the bag. Fractional knapsack ಪ್ರಾಬ್ಲಮ್ ಇದ್ದರೆ ನಾವಲ್ಲಿ ಐಟಮ್ಸ್ನ ಬ್ರೇಕ್ ಮಾಡಿ, ಐ ಟೋಲ್ಡ್ ಯು ಈ ಥರ ದಿಸ್ ಒನ್ ಆ್ಯಂಡ್ ಇದ್ರದ್ದು ಬ್ರೇಕ್ ಮಾಡಿ ಹಾಕಿ ಸೊ ದಟ್ ವಿ ಕ್ಯಾನ್ ಗೆಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಫಿಟ್, ಆ ಥರ ಮಾಡ್ಬೋದು. ಬಟ್ ಹಿಯರ್ ದಿಸ್ ಈಸ್ knapsack 0 to 1 ಹಿಯರ್ ವಿಚ್ ವಿಲ್ ನಾಟ್ ಅಲೋ ಅಸ್ ಟು ಬ್ರೇಕ್ ದ ಐಟಮ್ಸ್. ಐದರ್ ಹಾಕಿದ್ರೆ ನಾವು ಫುಲ್ ಐಟಮ್ ಹಾಕಬೇಕು. ಇಫ್ ವಿ ಆರ್ ಪುಟ್ಟಿಂಗ್ ದ ಐಟಮ್ ಇನ್ ಟು ದ ಬ್ಯಾಗ್ ಕಂಪ್ಲೀಟ್ಲಿ ವಿ ಪುಟ್ ಇನ್ ಟು ದ ಬ್ಯಾಗ್, ಅದರ್ವೈಸ್ ವಿ ಕೆನಾಟ್ ಪುಟ್ ಇಟ್. Okay, so that is adike this problem is known as 0 to 1. This is not a fractional problem, the fractional variant. This is 0 to 1 variant which which does not allow us to break the items while putting into the bag. So now clear the problem statement, why it is knapsack problem 0 to 1. So we also understood what is the concept of knapsack, what are the items, how to put the items into the bag. Now let us see the problem statement, that is given n items. So there are different items will be there, right? So total number of items is represented by n and each item has its weights, right? First item, the weight of first item, the weight of second item, like that up to the weight of n. And also each item is associated with profit, right? So the first item profit is represented as P1, second item profit is P2, like that. The nth item profit is represented as Pn. So and also the knapsack is nothing but a bag. The bag capacity which is W, or we can also call it as a M or W, anything we can take. So the capacity we can represent with the one variable. And find the most valuable subset. We need to do the subsets of items, so which exactly fit into the capacity. So we need to put the most valuable subset into the capacity, the fit into the knapsack, so which matches with the capacity of the knapsack. So this knapsack problem, the exhaustive search approach we are using here, so this will leads to generating all the subsets of set of n items given. So in this we have a different we can make a subset of n items. So while doing subset we need to consider two conditions. That is, while computing the subsets, the total weight of each subset should not exceed the capacity of knapsack. So we already discussed the total weight of these two. Suppose we are doing the subset that consists of this and this item. So then the total weight of these two, this subset, total weight of subset is 12 plus 4, which should not exceeds the capacity of the bag. This is first condition. Second condition, find a subset that gives the largest value. So we need to find which subset will give the largest profit. These two are very important. So now we'll move to the program now. Problem now. Here it is a knapsack problem. One example. There are three items. N is equal to 3. The capacity of knapsack we represented with the variable m. It is a capacity of the knapsack, that is 105. So now each item associated with weight as well as profit. We can see first item, weight is 100, profit is 20. The second item, weight is 10, profit is 15. The same way third item, weight is 10 and profit is 15. Now let us create a subset. So here subset, what is the total weight of the subset, and what is the total value, nothing but a total profit. So initially null subset means there is no item present in the set. Definitely weight is also 0 and profit is also 0. Second possibility, we can only put item 1 into the knapsack. So only one item means, so that one first item weight is 100 and profit is 20. Weight is 100 and profit is 20. The same way, so suppose we are putting this only second item, then its weight is 10 and 15. Weight is 10 and 15. Profit is 15. If we are putting only the item 3 into the knapsack, then its weight is 10 and profit is 15. Its weight is 10 and profit is 15. So again we can do the combination of different, we can do the combination 1 and 2, 1 and 3 like that. Now we'll see, we can do the combination 1 and 2. So we cannot do 0 and 1 because 0 is 0, again we'll get the same value. So for that we need to combine 1 and 2. So let us see 1 and 2. After combining 1 and 2, this is a subset which combines two items, item 1 and item 2. Item 1 weight is 100, item 2 weight is 10. Total weight is 110. You can see here. Total profit is 20 plus 15. 20 plus 15, that is 35. Okay. The same way we can create a subset which consists of item 1 and item 3. Item 1 and item 3. So item 1 is 100, item 3 is 10, 110. Total weight is 110 and 20 plus 15, that is $35. The same way we can create a subset with the items 2 and 3. 2 and 3. Say subset 2 and 3. 2 weight is 10, 3 weight is 10, total weight is 20, and so the profit 15 and 15, that is 30. Again one more subset we can create, that is 1, 2 and 3. One combination of 1, 2, 3. If we consider 1, 2 and 3, the total weight is 120. Total weight is 120, 100, 10, 100 plus 10 plus 10, 120. Profit 20 plus 15 plus 15, that is 50. Okay, now we'll see what is the meaning of feasible and infeasible. Here let us go for this. If we put only one item into the knapsack, its weight is 100, capacity of the knapsack is 105. 100 is less than 105. Yes, so this is feasible. So 10 is also less than 105 capacity of the knapsack, so it is feasible. 10 is also less than 105, it is feasible. 110, see your total, the weight here 110, which is greater than the capacity of the 105. Capacity ಬ್ಯಾಗ್ದು ಕೆಪಾಸಿಟಿ ಇರೋದೇ 105, ಬಟ್ ನಮಗಿಲ್ಲಿ ವೆಯ್ಟ್ ಇರೋದು ಐಟಮ್ಸ್ದು ವೆಯ್ಟ್ ಇರೋದು 110. Can we put this 110 weight into the bag of capacity 105? No, ಬ್ಯಾಗ್ ಕೆಪಾಸಿಟಿಗಿಂತ ಜಾಸ್ತಿ ಇದೆ, ಇದನ್ನು ಹಾಕ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಸೊ ಇಟ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ದ ಬ್ಯಾಗ್ ಕೆಪಾಸಿಟಿ. ಆವಾಗ ಈ ಥರ ಇದ್ದರೆ ಇದನ್ನು ನಾವು ಇನ್ಫೀಸಿಬಲ್ ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ. The same way we can go to the next one. Here also next one, the 110, which is greater than the capacity of the bag, so it is infeasible. Come to the next one. So here we can see the weight is 20, but capacity is 105. See, capacity 105 ಇದೆ, but ಇದ್ರ weight ಇರೋದು ಮಾತ್ರ 20ನೇ. ಸೊ ಹಾಗಾಗಿ it is feasible. Okay, so we'll go to the last subset. Here the weight is 120, but capacity ಇರೋದೇ 15. ನಾವು 120ನ ಹಾಕೋಕ್ಕಾಗಲ್ಲ ಅಲ್ವಾ, ಸೊ this is infeasible. ಸೊ ಅಮಾಂಗ್ ದೀಸ್ ಫೀಸಿಬಲ್ ಏನೇನು ಬಂದಿದೆ ಅದರಲ್ಲಿ ಯಾವುದು ಪ್ರಾಫಿಟ್ ಜಾಸ್ತಿ ಇದೆ? ಲೆಟ್ ಅಸ್ ಸಿ ಹಿಯರ್ 20, 15, 15, 30. Out of these, the maximum profit is 30. So this is the optimal solution for the given knapsack problem. Here item 2 and item 3, which gives item 2 and item 3, which gives optimal solution with the maximum profit of 30. Okay, so now I think you understood the knapsack problem. Now let us compare the algorithm with the traversing. Okay, so say by taking the same example, algorithm start with the keyword algorithm, and the algorithm name is knapsack. This is I comma m. So now we'll see what is I comma m. So the I comma m are the parameters, input parameters. So initially we start with the item 1, checking from the item 1 to item n, how many items are there, right? So start with 1, and this indicates the capacity of the knapsack. This indicates capacity of knapsack, that is represented with the variable m. So the aim of this algorithm is it implements knapsack algorithm using exhaustive search method. Inputs are 1 as well as capacity of knapsack m, and the output which gives optimal solution with maximum profit. ನಮಗೆ ಫೀಸಿಬಲ್ ಸಬ್ಸೆಟ್ ಸಿಗುತ್ತೆ, ಆ ಫೀಸಿಬಲ್ ಸಬ್ಸೆಟ್ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಫಿಟ್ ಕೊಡಬೇಕು. ಆ ಥರದ್ದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಅದು ಎಷ್ಟು ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಫಿಟ್ ಸಿಗುತ್ತೆ, ದಟ್ ವಿಲ್ ಬಿ ರಿಟರ್ನ್ಡ್ ಬೈ ದ ಆಲ್ಗರಿದಮ್. ಸೊ ನಾವು ವಿಲ್ ಸಿ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್, ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ ದೇರ್ ಆರ್ n is equal to 3 and the capacity of the knapsack is 105. Okay, so the n is equal to 3 number of objects or number of items. So item 1, item 2 and item 3. Here this is, let us start with, it starts with 1 comma capacity is 105. It start with the algorithm start with 1 and 105. I is equal to 1, m is equal to 105. Now it will come here in the if loop, I value is 1, right? So 1 equals to n value is 3, total number of items 3. 1 equals to 3 condition fails. So it will come to the next case if weight of 1 greater than capacity of knapsack. Weight of 1 greater than 105. Weight of 1 is 100. 100 greater than 105. Is it true? No, this condition fails. 100 is not greater than 105, right? So it will skip this and will come to the next. So it will come here, then it will execute this return the again one more algorithm max. Okay, it is calling the algorithm max. It will jump to the max and it will execute this. So for the max algorithm, there are two parameters, right? A and B. So the A, for the A value, after processing this first parameter, it will send the result to the variable A. The second function knapsack of I plus 1 comma m minus w of I, this complete, after processing this, the result will be, and after processing this, that the result plus added with this will be sent to the B. Okay, then when it enters to the max function is very simple. So it will check out of A and B which is the largest one. So it finds the maximum between A and B. So it will, if A is greater, here we can see if A is greater, it will return A, or else it will return B. So here, so it came here. So I is equal to 1 we are discussing now here. I is equal to 1 and M is equal to 105. These two condition failed, so it came here, right? So here knapsack of 1 plus 1, that is 2 comma 105. We can see here it will call the function again. The problem again go to the sub problem. Sub problem ali again calling the same function with the parameters. It is calling the same function with the parameters 2 comma 105. The same way, the again one more parameter, again this will call the function with the parameters 1 plus 1, that is 2 comma M is 105, 105 minus weight of 1. Here weight of 1 is 100, that is 105 minus 100. This is the parameter again. So we can see the profit of 1. The profit of 1 is 20, that is plus 20. After processing this, the result will be added with the 20. So again these two different again sub problems, right? So again it is calling the knapsack. So here I is equal to 2, M is equal to 105. I is equal to 2, M is equal to 105. This will come here. 2 equals to 3. N is equal to 3, right? 2 equals to 3. Is it true? No. It comes here. Weight of 2 is greater than M. Weight of 2 is 10 greater than 105. 10 greater than 105? No. This condition also fails. So it will come here. Again it will go to the max function. So we can see here again it will go to the max function, max of, again two different sub problems again, that is knapsack of 2 plus 1, that is 3 comma M value is 105. 3 comma 105. The same way second parameter knapsack of 2 plus 1, I is 2, right? 2 plus 1, 3 comma this 105 minus weight of 2. Nodi 3 comma 105 minus weight of 2 is 10. Weight of 2 is 10 plus profit of 2. See here profit of 2 is 15 plus 15. Okay. So this again we can see here this knapsack, again it will call the functions with the same parameter. I is equal to 3, then M is equal to 105. Come here, I is equal to 3, M is equal to 105. Here come here, if 3 is equal to 3 condition true now. Yes. So if it is true, it will come here return. This is ternary operator. If this condition is true, weight of N is greater than M condition true, it will return 0. Otherwise, if this is false, it will return the next one, profit of N. Here I is equal to 3. I is equal to 3 and M is equal to 105. So weight of N, weight of 3 is greater than 105. Weight of 3 is 10. Weight of 3 is 10, which is greater than 105. Is it true? 10 greater than 105? No, this is false. So it will return the value profit of N, profit of 3. So profit of 3 is 15, right? So it will return 15. 15 is the returned value from this algorithm. Okay, it returns 15. Again the other function, other algorithm, again parameters I is equal to 3, m is equal to 105 minus 10, that is 95. 3 and 95. 3 and 95. It will come inside 3 equals to 3. Is it true? Yes. So it will come here return statement weight of 3. So weight of 3 is, what is the next weight of 3? So weight of 3 is 10. 10 greater than m. M is 95. That is 10 greater than 95. Weight of 3 is 10. 10 greater than m value is 95. 10 greater than 95. It is false, right? So then it will return the value profit of 3. That is profit of 3 is 15. So this complete this 3 comma 95 which returns the value 15, which should be added with the 15 previously our this profit. Okay, so here already written this 15 is added with the returned value 15. Total value is 30. Okay, so here it returns 15, it returns 30. So now 15 and 30 are the parameters. 15 and 30 are the parameters to the function or algorithm max. Now here for the max 15 and 30. Out of 15 and 30 it will return maximum element. So 15 and 30, if 15 greater than 30, it will return 15, otherwise it return 30. Of course 30 is the largest, so it will return 30. So we can see here 30 will be returned back here. For this problem, subproblem, for this subproblem, again these two are the subproblems. The optimal solutions of these two subproblem is 30. 30 is the result here. 30. Max of 30, and we require one more value here, right? So let us go for traversing this. This is I, this is m. I is equal to 2, m is equal to 5. So come inside. I is equal to 2, m is equal to 5. So 105 minus 100 means 5. So here come here 2 equals to 3 condition fails. So it will come here weight of 2 greater than m. Weight of 2 is 10 greater than m value is 5. Right, m value is 5. 10 greater than 5. See here 10 greater than 5. It is true. 10 greater than 5 is true. Here weight of 2, 10 greater than 5. If this is true, it will come here. It will return. Again call the function knapsack of 2 plus 1, that is 3. 3 comma 5. ನೋಡಿ ಇಲ್ಲಿ 3 comma 5. Again ಈ ಫಂಕ್ಷನ್ ಇಂದ ಇಲ್ಲಿಗೆ ಬಂತು. I ವ್ಯಾಲ್ಯೂ ಈಗ 3, m ವ್ಯಾಲ್ಯೂ ಈಸ್ 5. ಅಗೇನ್ ನ್ಯಾಪ್ಸ್, ಸೊ ಮತ್ತೆ ಈ ಫಂಕ್ಷನ್ ಕಾಲ್ ಆಗುತ್ತೆ. ಸೇಮ್ ಫಂಕ್ಷನ್ ಕಾಲ್ ಆಗಬೇಕಾದ್ರೆ I change it to 3 and m value is 5. Okay, so again 3 comma 5 we can see. Again calling the knapsack function with these parameters. Now we'll traverse this 3 and 5. 3 equals to 3 condition true. So it will come here. So it will check for the condition weight of 3 greater than 5. 5, m is equal to 5, right? Weight of 3 is 10. 10 greater than 5. True. 10 greater than 5 equals, it's true. So if this ternary operator, if this condition is true, it will return 0. If this condition is false, it will return this, right? So since it is true, it will return 0. So see here, this will return the value 0. Along with this value should be added, right? 20. So adding 0 plus 20, same value it is. So here this one, this is separate value. This is adding here 0 plus 20 is total 20. 20 is the result of this subproblem of this subproblem is this subproblem is this. Like this we got the result 20. 20 is here, that is already we got 30 for this and 20 for this total. So max of 30 20. See here, again it will call the function return max of 30 comma total 20. So we can see here complete bracket. So this complete result 20, this result is 30. This subproblem result is 30, this complete subproblem result is 20. Now it is calling max of 30 comma 20. So again it jumps to the max function. 30 is assigned to A, 20 is assigned to B. Again 30 greater than 20. No, this condition fails. So sorry, 30 is greater than 20. This is true. It will return 30. Okay. So it will return the value that is 30. 30 is the optimal solution for the program. Knapsack problem. See here, we already discussed 30 is the optimal solution. This is feasible solution and it is also optimal solution. Okay. Anyhow, this is where I think you understood algorithm now. Now let us move to the time complexity and space complexity. The algorithm efficiency is measured by the term time complexity and space complexity. So here let us discuss first time complexity. This algorithm is based on brute force exhaustive search method. We take all possible item combinations, right? So for any n items, the total number of combinations is represented as sigma of I is equal to 0 to n, the function of I comma n. So I starts from 0 up to 3. So example we'll see here. There are n is equal to 3. It start from 0 up to the n, total 3. So we are just doing the sub combinations, right? How many combinations we can do? If n is equal to 3, 2 to the power of n. 2 to the power of n means by substituting the value 2 to the power of 3. So 8 combinations, right? So 2 to the power of 3 is 8. So here we can see 1, 2, 3, 4, 5, 6, 7, 8. 8 combinations we can try. We can see whether which one will give feasible and so which one is the feasible subset and will give the maximum profit, right? In order to find the optimal solution, so we need to do the subsets. 2 to the power of n combinations we can do, right? So this is what the time complexity of this approach. Knapsack time complexity is big O of 2 to the power of n. If there are only 2 items, 2 to the power of 2, that is total 4 subsets we can create and check. So while doing the subsets, while doing the combinations, we pick the combinations so that ಹೇಗೆ ನಾವು combination ಮಾಡ್ತೀವಿ ಅಂದರೆ those combinations satisfy the constraint. We know already the weight of the total weight of that combination should not exceed the capacity of the knapsack, as well as the total profit, summation of that profit, which gives the maximum value, like that. So these two are the constraints we should follow. So hence the time complexity is big O of 2 to the power of n. Now we'll move to the space complexity. Here auxiliary space is big O of 1 as no extra data structure is used for storing the values. 0 to 1 knapsack problem has two important properties, that is overlapping subproblems and optimal substitute. Here we can see, so when the problem is divided into subproblem, again divided into subproblem, right? See, a problem is divided into subproblem. Again, subproblem is divided into in turn subproblem. Here we can observe there is no common subproblem. Each one is different. Each one values are different. Each one is executing at only one time. Here there is no common subproblem. If there is no common subproblem means no need of storing this value, so for the further process. Okay, so here there is no point in storing the solutions if they are not needed again. This problem does not have common subproblem. So second thing is optimal substitute. So optimal solutions of the given problem can be obtained by using optimal solutions of its subproblems. So we are getting the total optimal solution for this. So after combining the optimal solutions of these two, again this will get the optimal solution. Optimal solution of this will be given to this, and the optimal solutions of these two will be combined to get the optimal solution for the main problem. So hence there is no common subproblem, so no need of storing the values. So for that reason the auxiliary space complexity is big O of n, big O of 1. So I think you understood space complexity. Now we'll move to the software requirements, how to execute your program. Anyway, we can execute in operating system Windows as well as Ubuntu. First, let us see operating system Windows. We can install Turbo C or Turbo C++. So these are the steps to be followed in order to uh, download Turbo C++ compiler and run our programs. So first we can download Turbo C++, download, and we can set up, we can install it, and it will create a shortcut key on the desktop. Click this and start Turbo C++. It will open the editor where we can type our program. So second option is we can go for operating system Ubuntu. So Ubuntu, we need gedit text editor. Gedit text editor can be get by using the command sudo apt install gedit on the terminal. So then we can create and open our file using gedit filename.c. So once the file open, then we can say type our program, we can save our program and compile a program using cc filename.c. Then we can run our program using the command ./a.out. Now we'll move to the demonstration of this program using Turbo C++. Now we'll go to the program. We can save our file as this is knapsack kn.c. Here we can type our program. Header file, stdio.h, header file, conio.h. Next that is macro definition. Macro name is max, value is 50. So there are two arrays, that is profit array of max, comma, one more weight array, that is and the total number of items n. This is global declaration. Now let us declare a function, declaration of function knapsack. Knapsack. So the parameters are of type integer. So int comma int. First one is 1 parameter, second one is the capacity m. So both are integers. So int comma int. Next, one more function we are using, that is max function. Parameters a comma b, that is both are integers. So int comma int. So now we'll move to the void main function. So let us declare local declaration here inside the function, the capacity of the knapsack m, and the one more parameter we require for the for loop I, and in order to store the optimal solution we require one variable, that is OPTSOLN. Now we'll printf. First we need to enter how many items. So enter the total number of items or objects. Okay, items or objects. Scanf. So for the objects, total number of objects, we have taken a variable n. So ampersand of n. Next is we need to enter the weights of all objects or items, that is printf enter the weights of all objects. So weights, that is n, where n items are there, so for that reason we need to use for loop. This is a weight is array, so we have weight is array, weight and profit is array, so we are using single dimension array, that is for I is equal to 1, start from 1, and I less than or equal to n, then I plus plus. Let us scanf percentage %d, comma, ampersand of weight, next is, so we need to enter the profit. It will ask us to enter the profits. So for profit is also array, so we are using a for loop. Next, scanf percentage d, comma, ampersand of profit of I. So next remaining is we need to give the capacity of the knapsack. So printf, enter the capacity of knapsack. Capacity of the knapsack, we are using the variable m, that is ampersand of m. Now we gave all the total number of items, weights and profits of all items, as well as capacity of the knapsack. Now let us call the function. So the returned value will be assigned to the variable optimal solution is equal to function name is knapsack. Parameters are first object 1 comma capacity m. This is calling the function. Next, printf, we can print the solution, okay, that is the optimum the optimal solution is percentage d, comma, get ch. In order to see the result on the screen, get the characters, we are using get ch, which is associated with the header file conio.h. So clear the screen. When we get the output, we are using clear screen, which is also written under header file conio.h. Now we'll move to the algorithm, that is function knapsack, that is return type is int, function name is parameters int I comma int m, capacity of the knapsack. Next is we are just check the condition first, whether I is equal to n, means if only one item is there, it will check whether the weight of that item return, that is weight of n is greater than m, capacity of the knapsack. If weight of 1 is first element weight itself greater than the capacity of the knapsack, it is not possible to put that item into the bag, so it will return 0. Otherwise, if the weight is less than the capacity, we can put, so the profit of that particular item is considered now. Next case is, if first if case fails, it will go to the next if case. Here it will check for the weight of n, with weight of I, which is greater than m. If this is true, it will return, again call the function, it will with the parameters, that is I plus 1 comma m. If this condition fails, again it will move to the next statement, return of max of again the function knapsack of with the parameters I plus 1 comma m comma knapsack of I plus 1 comma m minus weight of that object, close bracket. This is the function. The result of this should be added with the profit of I. This is end of the max. So next, this ends the knapsack function. Now let us write one more function, that is here max function is there. So let us include max. Now the parameters also integer int a, formal parameters, right? Let us consider with the variable int a and int b. Next, so here it will check for the condition if a greater than b, it will return a, else it return b. Okay, this is end of the function. Now we'll check the program. This is the header file stdio.conio. This is macro definition. Maximum array capacity is 50. Wherever we write max in the program, that will be substituted by the max value 50. So here there are two profit and weight array. This is function declaration. This is max function declaration. These are globally declared. Void main. These are the local variables. Now we enter total number of items, total number of weights, as well as total number of profits. These are the total number of profits. Then the capacity of the knapsack. Call the function here. That returned value will be assigned here, and we can print using printf statement. Now let us compile the program. Zero. Then run the program. So what we discussed now, the same thing will give as an input. Total number of objects 3, the weights 100, 10 and 10, profits 20, next profit we gave 15, next gave 15, again knapsack capacity we gave 105, right? So we go solution, we need to get 30. So we got the result, we got the correct result. Again we'll check for one more case, one more input. Enter the number of objects 3, weights let us give 5, 3 and 4, the profits 20, 40, 30, and let us give the capacity of the knapsack, that is 10. The optimal solution we got is 70. So let us analyze how it is 70. So now we got to know how to execute our program. So this is the way how you can execute it. Now let us continue with the explanation. So anyway, we got to know the program, how to execute it. Let us analyze the output what we gave. Right, enter the number of objects 3 we gave, weights 5, 3, 4 and the profit 20, 40, 30 and the knapsack capacity 10. Then we got the optimal solution, that is 70. Let us analyze this. So first we take 0, definitely weight is 0 and profit is 0. If we consider the first item weight is 5 and profit is 20. And see the second item weight is 3 and 40. 3 and 40. So now the third item weight is 4 and 30. 4 and 30. The next subset consists of items 1 and 2. 1 and 2. 5, 3, that is total weight is 8. Total profit is 60. Let us consider one more subset, that is consists of item 1 and item 3. So 5 and 4, total weight is 9. That is total profit is 20 and 30. That is total profit is 50. Let us do the subset by considering item 2 and 3. 2 and 3 means 3 plus 4, 7 weight. 40 and 30, total profit is 70. Last subset, that is 1, 2 and 3. The total weight is 5 plus 3 plus 4, that is total weight is 12. and the total profit is 20 plus 40 plus 30, total 90. So here let us see what are the feasible and infeasible. This is not exceeding the capacity of the knapsack. Here capacity of the knapsack we gave is 10, right? So 5 is not exceeding, 3 is not exceeding, 4 is not exceeding, 8, 9, 7, but 12 is exceeding the capacity of the knapsack. So this is the infeasible. We cannot consider this infeasible subset, infeasible solution. Now remaining all feasible, but here we need to consider the maximum profit out of this 20, 40, 30, 60, 50, 70. The maximum is 70. So by the subset consists of item 2 and 3, which will give the optimal solution with the maximum profit, that is 70. Let us see the output. The optimal solution we got is also 70. So this is the way how knapsack program works. So this ends the session. Thank you.